Let's look at the next problem. Okay, here it says the flow rate from a tap of diameter 1.25 centimeter is 3 liter per minute. The coefficient of viscosity of water is 10 to the power of minus 3 Pascal second. Characterize the flow. Characterize the flow in the sense, is it streamline? Is it laminar? Streamline, laminar, pretty much the same. Or is it turbulent? Okay, you have to calculate. This is how we say characterize the flow. Now, what parameter gives you whether the flow is turbulent or streamline? Critical velocity and Reynolds number, correct? These are the two parameters. Critical velocity, you won't be able to calculate it directly. So what we'll use? We'll use Reynolds number, because you know anything between 0 to 2000 is streamline. Anything more than 3000 is turbulent, correct? So that gives you a number, that gives you a value. Let's try to use Reynolds number and do it. Okay, first is the formula, obviously. What is the formula for Reynolds number? You have NR, this is the Reynolds number, correct? NR is equal to rho d Vc divided by eta. This is the formula for Reynolds number, correct? Density, diameter, critical velocity, and coefficient of viscosity. But if you look at the question, see the diameter, at least you have a value for diameter. See this one, 1.25 centimeter. You have the viscosity, correct? But the 3 liter per minute is there, correct? So that some or the other way you have to figure it out. So what we'll do, we'll look into the next part, which is the critical velocity. See this part, we see whatever we have. We'll try to figure out with respect to the 3 liter per minute. Okay, let's rearrange this particular formula and see how we can solve it. Now what you have, NR is equal to rho d divided by eta into, see critical velocity, we have volume V divided by area, pi r square or pi d square by 4. Pi into d square divided by 4. See, now what you have, the 4 and d gets cancelled, correct? Simplify this, you will get 4 rho into V divided by eta into pi into d. What we just did is that we wrote the Reynolds number in terms of the whatever is the flow per unit time. Okay, the flow of liquid in the unit time. Now, rho, density of the water, we already know the density of water. Volume, we know that. Eta, we know. Capital D, we know. We pretty much have the entire value. So let's look at this one. So what you get is that 4 into density 10 to the power of 3 into 3 liter per minute. 3 into 10 to the power of minus 3 divided by 60 minute, right? Divided by next eta 10 to the power of minus 3, 22 by 7 into the diameter. See, diameter is 1.25 centimeter, so into 10 to the power of minus 2. Guys, you need to simplify this. This is quite a big number to simplify, correct? Now, once you simplify this one, you will get an answer 5090. Understood? Now, since you have 5090, the Reynolds number is 5090. Now, what we know is that anything more than 3000 is a turbulent motion, correct? So, what we get from this one is that since NR is greater than 3000, therefore, the flow is turbulent. The flow is turbulent. So when they say characterize the flow, you can write the answer by calculating Reynolds number and say whatever is the answer. For this particular question, the answer is the flow is a turbulent flow. Clear? This is the answer for the given question.